Hello everyone, my name is Arnav Rajchodhuri. In the task 1 of Data Science and Business Analytics internship for the Sparks Foundation, we are going to predict the score of a student based on the number of study hours. And we are going to predict if the student studies for 9.25 hours, how much is that person is going to score. And we are going to use linear regression model. Firstly, we will import all the libraries, that is pandas, seaborn, numpy, matplotlib, etc. Then we will read the CSV file, that is student underscore scores. From there, we can see that there are two variables, that one is hours and another one is scores. The distribution of exam score and the distribution of our study shows us that it follows a bimodal distribution. That means there are two peaks, as we can see from the distribution, and it tells us that there are two separate groups of students. One group is underprepared and another group is over-prepared for the exam. Now if we check the correlation among hours and scores, we find that it is highly positively correlated, and the correlation value is 0.98. Now we get the values of the dependent variable and the independent variable. The dependent variable is y, that is the score, and the independent variable is x, that is hours studied. And we split the data, the total data, into training data and testing data using train test split from sklearn's model selection. And while splitting the data, we get 0.25 testing data, that is 20% data is used for testing and remaining 80% for training the model, and the random state is 42. Now we import the linear regression model and feed the data, the training data, to it, and use it to predict the values, the testing values. And here we can see the actual values and the predicted values using our model. And we also calculate the score of our model, which comes to 0.967 or approximately 97%, which is the R square. So 97% changes in score is due to change in number of hours studied. Now if we visualize the data in a plot, we can see that for training set, the red dots represent the actual values and the green line represent the regression line or the predicted values. Same for the testing data, the blue dots represent the actual value and the green line represent the predicted value. And if we draw a box plot, and in the box plot if we plot each data, we see that there are no outliers. That means all the data points are within the whiskers. After that, we can see that in the plot, in the predicted value and in the actual value, there is some difference. To check out how much is the difference, we use these three metrics, that is mean squared error, root mean squared error, and mean absolute error. Mean squared error is 18.94, root mean squared error is 4.35, and mean absolute error is 3.9. And for the final question, to predict how much the person will score if he studies for 9.25 hours, we use our model to predict the value, and the value is 92.38. So but we have seen that there are some errors in actual value and predicted value. So we need to calculate the prediction interval, which is predicted score plus minus 2 into RMSE or root mean square error. So it comes that predicted interval is 83.68 to 100 for 95% accurate prediction. Thank you very much.